This is interesting. James Joaquin just joined, I think. If that's who I think it is, if it's the real
That's
one,
me.
it is
Greetings.
him. There he is.
You confirm your
Hello.
voice print.
You're, yeah, exactly. So you're just in time to hear Walter um, tell you all his big news about
I don't
Newton
have news.
script.
I'm just taking questions.
I saw Walter on the agenda. Thank you, Adam, for sending it to me.
Mhm.
You got it.
And now I can
So,
defer all questions to James, so that's handy.
okay, so who has some questions for Walter today?
This is where the
Would it be?
embarrassment begins.
Maybe, Walter, you can tell us a little bit about your story at Apple.
Well, so it's a little weird because I showed up much earlier than there was a Newton script or the Newton that shipped. So James and I lived through many years of things you would not recognize because they never shipped. Um, but I first showed up. I was an intern um, from Carnegie Mellon. I showed up the same summer as Michael Culbert, who did a lot of the hardware work. So we were both, I'm sure, the youngest people there. But it was a very egalitarian kind of place, and nobody seemed to care as long as we did something interesting. So when I got there, it was just a research project. Basically, it was just like grad school. There was no plan. So everybody was just working on a bunch of different things, and the hardware people were working on crazy new hardware, and the software people all had little individual software ideas, and that went on for years, several years, and it never really converged on anything. And so we reached a kind of a crisis point where that mode was not really going to work anymore, and the people who actually ran the company wanted us to maybe produce a product at some point instead of just talking a lot and producing prototypes of things. And so there's kind of two phases because up to that point it was a very different feel because it was just working on whatever things seemed interesting and just find whatever cool idea you were interested in working on and seeing if you could apply it to this problem. So it really didn't have any limit on the amount of innovation that was allowed to happen, which I now understand as a somewhat more experienced engineer is a good thing to have. Is maybe only invent one or two things, not 16 things on the same project. But a lot of that stuff, it created a kind of a atmosphere of ideas that many of which kind of survived in some form, even though maybe the code didn't survive. And so I think there's this sort of intermediate phase where it did sort of start to converge, and it converged from a couple of different directions at once. And I think one thing about the Newton team that is I've not seen really since then is very strong individual owners of stuff. So, like at Microsoft, if you had somebody writing a new language runtime and a compiler to go with it, that would be like a team of 15 people, or if you had somebody making a new user interface framework or a new TCP networking stack, that'd be a half a floor full of people. In Newton team, that was like one or two people. And I don't understand how that worked other than everything was kind of smaller back then and everybody was just really smart. But the result was that you could have a very productive conversation. You could, if you wanted to have some hook into the operating system to get your language to work, you would just go down the hall and talk to Bob, and then you got it. And everybody was kind of in this mood of inventing things. There was no existing thing to be compatible with, so everybody was really open to having some crazy idea of how to do that. And also very open to, well, this is the 1.0, so why don't we just hack that and we'll get it to work and we'll figure that out later because we don't have time right now. So it was someone, I forget who said this first years and years ago, but it was more like being in a jazz band than a symphony. So everybody kind of had their own little area that they owned, and they did their thing, but they were listening to everybody else and getting those connections to work. So once we kind of got into that mode, and also stopped sleeping, it really increased the rate of convergence and producing a particular product. And of course, during all that time when engineering was doing that, James and his pals were trying to figure out how we're going to explain what this is. Why would anyone want to buy this? So, hopefully we get that feedback as well in a product. So you end up with something that's kind of sellable. So it really went from this weird kind of long-term, unscheduled, I mean, we pretended it was scheduled, mishmash of stuff. It pretty suddenly became the thing has to ship, and it's got a year, and it needs to become real immediately. And that was kind of the phase change. But it wasn't like we changed the team. Everyone just sort of realized, okay, now we're acting a little different. And it really changed the day-to-day of it into more of a, we need to land this thing, as opposed to we're going to explore every star in the sky, which is what it was like before. And at the same time, there was this sort of parallel project that the big Newton, that was the last stages of sort of the original approach, because I think there were still people very excited about the original approach, and they wanted to see, well, why can't we make that be a product too and get that to converge? I think it was just that was so huge, it just didn't have time or enough energy or kind of a product vision to coalesce around, which the little one did. So the little one kind of took over the course of several months. So as someone working there, it went from intern on crazy research project to whatever 16-hour a day, just cranking out code to get this thing to ship. And it was a definitely an interesting journey from a career perspective, because that was my first actual job. so that, I mean, that's not how it's supposed to be. Nothing else was ever like that. So that didn't really help in the future understand how to operate in a company. But I think the other thing that was also I never really saw again was outside the company, and you can still see this happening right now today. Just the external audience was also very strong. So early developers, for example, there weren't a whole lot of them, and they were all incredibly engaged. And you could go to the developer conference and have hours and hours of conversation, and it was more like working with somebody, as opposed to today, if you're working on iOS, there's a million developers literally, so it's kind of a one-way conversation most of the time. You don't really get to collaborate. So that was really fun, because you get to finally show people what you're working on, and it's not quite done yet, and they actually have the opportunity to change what you're doing, and you can really get some good feedback. Which again, because it was smaller, you could actually do that, and now it's a lot harder to do. I'm just rambling at this point, but that to me is what I remember is just the team was great, and the project being so greenfield, being not worried about compatibility and trying to invent a new thing was really cool.
That's great. Thank you. I think Jason, you have a question.
I was wondering with Newtonscript, if you had anything that influenced you as you were developing it, like for example, say HyperTalk or SkateScript or anything like that.
Oh, sure. I actually wrote a little article about this that's on my website someplace. But so back when it was the big Newton, and we didn't really know what we were doing, one of the questions was, what are we going to write all of this in? And this was 1988 and 9. And the answer was not obvious, because it's, nowadays there's a lot of really well-established, robust languages to choose from. In 1988 and 9, that was not true. There was basically C, and Pascal was big at Apple. Object Pascal was an Apple extension. C++ was new at that point. In fact, it was still a preprocessor. It wasn't even a compiler anywhere yet. So it was called C-front, and it would convert your C++ code to C, which you would then compile, which is not fast. And there were lots of other things. There's Eiffel, you know, there's Modula 3. There's all kinds of great languages that no one's ever heard of nowadays. Smalltalk, you know, was still a fairly recent language back then. So anyway, we were trying to figure this out, and it caused this whole, again, a research project to figure out, well, if you were going to start over and pick, you know, the language that people should be using, which one would it be? And we eventually settled on thinking it's a kind of Lisp, and then actually buying a little company in Massachusetts that made Macintosh Common Lisp, which is awesome, by the way, if you like Common Lisp. Still is. And basically turning them into a piece of the advanced technology group and saying, okay, your job is to invent this new dialect of Lisp that we're going to build Newton in, and build the compiler, figure out the language, all that sort of thing. So, you know, typical old Newton style, we're gonna make this big investment and start this 2-year-long project to make a completely new language that we're going to build this thing in. See, that seems like a dumb idea to me now. Anyway, it was a very cool language, and the problem was that it had a couple of big problems. One is it was taking a long time because that's not actually a very fast thing to do. But also the processor that the hardware people had chosen was totally inappropriate for that language, because that was an independent decision. The hardware guys had said, we need a low power processor, and they started a whole new processor project. And the software people said, we need a cool new language, and started a whole new language project without actually, you know, communicating. So fortunately, by accident, sort of, that got fixed because we switched processors to the ARM, a whole other story. And so that was officially the language. That was the big Newton language, was called Dylan, which was that new Lisp dialect. But the process of going through all of those different languages to figure out what the next one was a great education. It was like going to grad school for language design, in a sense. Like, you got to write a survey paper. So then much later, when I accidentally made a language, all those, you know, ideas were still floating around. So I could kind of pull things from different places that seemed to make sense. So it ended up being a really weird combination, because it's got a syntax kind of like Pascal, because at the time that was what people programmed Macs in. And so we thought that would be a more familiar syntax. Nowadays you look at it, you're like, what are all these words everywhere? But that was normal then. It has an object structure that's copied more or less from Self, although simplified. And Self is a very early prototype-based language that was very inspirational in terms of just the structure of the objects, and also how the runtime works, like how functions get called, and just the kind of interpreter loop. So that was good. And then I think there were some, like the name, you know, Newtonscript is reminiscent of AppleScript, and it was because it was supposed to be a language specific to the Newton. And that seemed like an easy way to get that idea across. You know, like, you're not going to go write something else in this. This is for writing Newton applications. But primarily, if you kind of take the syntax off, it's kind of Self and Scheme munged together in a weird way. And I snuck some things in there that would have been weird to programmers at the time, like first class functions, and being able to make an anonymous function call with the call with statement. You can't do that in Pascal. That's just weird. You know, or having closures, that kind of thing. But we kind of got it under the radar by making it look a little more normal. If it was all parentheses, people would have freaked out. Still would.
Great. James, I know that you had a different experience from Walter's side of Newton. What was your experience with Newton?
Well, my experience was definitely a Venn diagram overlap with Walter, but I was the second marketing person to join this top secret R&D team. Michael Chow was my boss. And so I had the great pleasure of working closely with Walter and Steve Capps over the years to take this thing, which was, you know, Noah, in your documentary, I think I described it as like stacking risk. We just had all of these R&D projects Let's design a new operating system. Let's design a new processor. Let's create a whole new joint venture to create ARM. Let's add a new input model. Let's add natural language processing intelligent assistance. Let's create a new programming language, and just do it all at the same time. And if you think about modern software engineering and hardware development projects today, nobody would do that. It was just it's like n squared risk, but we were just young enough and inexperienced enough and crazy enough to do that. And part of my journey was on the marketing side, as Walter said, figuring out, okay, this is technology in search of a market. What can we actually do with this? What are the practical applications? And I had a lot of fun as the product manager of the OS and of the development tools and of the programming languages, to work with early developers. And we were so obsessed with secrecy, and I think Apple still has this culture today, but as Walter hinted, we're making everything at the same time. So we would do these developer kitchens, we called them, where we would invite certain early developers, and they had to sign a huge stack of NDAs, and we gave them a motel room in Cupertino, and they literally came into a locked room where they would get access to the early operating system and the development tools and build apps. And we would do it with them and get their feedback and change the OS or change the tools based on what kind of walls that they hit trying to code up a particular app. So it was really, really cool to be that collaborative with early developers. I think a couple of pieces I would add to Walter's story is that from the business angle, we had a lot of external pressures from the market because our CEO at the time, John Scully, was pre-announcing so much of Newton, but we also had corporate pressures versus other groups. So you can think of this as it's like a pirate ship within a pirate ship, where the Newton team, where we were flying the pirate flag and we were trying to create the next thing after Macintosh. But there was a much, much bigger Macintosh team, and they had a line of successful laptops called PowerBook. And there was a team within that group trying to build a smaller PowerBook that would take the Mac OS and shrink it down. And we had time pressure from them because they were telling senior management, hey, cancel this Newton thing. We can do it. We can do it on Mac OS. And then within Newton, we had all of the legacy of the original Hobbit processor pivoting to the ARM processor, this programming language that I was product manager of that I named, called Dylan, DY for dynamic, LAN for language. And that thing was this huge beast built by the Macintosh Coral Lisp team. And I got to work with David Moon, one of the legendary creators of Lisp. But at the same time, I was trying to tell that team, hey, developers don't want a parenthetic notation language to build apps. We have to make this, something more familiar, algolic syntax. And so within that pirate ship, we then had a smaller pirate ship, which was led by Caps and Chow and Walter and Colbert, saying, hey, why don't we just build something smaller that we can ship that's more of a pocket-sized Newton as opposed to this tablet-sized Newton, which was too close to a laptop for the market to understand. And it was codenamed Junior. And that's really, Newtonscript was the kind of just-in-time language for Junior, while we were still creating this giant Dylan development environment for this giant tablet-sized, much higher-priced thing. And so the mini pirate ship ended up winning the race, and that's what we ultimately shipped as the message pad.
And you didn't even mention General Magic in that explanation.
Or the whole Paul Mercer, moving from the PowerBook team to the Newton team. There's a whole bunch more stories in there, right, Walter?
I was actually reading the other day about Brendan Eich in JavaScript and in Netscape, and basically somebody saying we need a language for this browser thing, and you have 4 weeks, go. So I know how he felt. But I think it's actually an interesting thing that it doesn't really show up in the histories or anything. I'm sure this is true of all history, but in particular of Newton, is if you look at it from now, you get this linear view because you only look at the things that survived until the end. But in the process of building it, there were all of these branches happening, and all of them, well, not all of them, most of them are really interesting branches. They just didn't and of
Yeah, we
shipping.
had
So,
a
like we invented
diffuse
Wi-Fi.
infrared,
Right.
diffuse infrared in-room networking. Remember that, Walter?
But before that, we actually had radio networking, and the people working on it realized the long pole in that is going to get FCC approval. It's not even the technology; it's getting the frequency bands. So I forget his name, but he left the team and went off to sort of do this long-term project of convincing the FCC to let this be a thing. And that's the reason one reason we had to switch to infrared. So it's just all these things kind of, you know, they started and then they kind of got ejected, but they still happened, you know, and some of them didn't. But.
If I may, I wanted to suggest one prompt for you, Walter, which is to talk about the frame store. I think it's such an amazing piece of technology and innovation out of the original Newton OS, and you were very much the father that gave birth to that.
You mean like soups and stuff?
Yeah. Exactly.
Well, see, that's another one of those
soups across apps.
Yeah, well, that's another one of those ideas that just comes from reading too much. So, back in the day, persistent object systems were a big research topic. So late 80s, early 90s. I'm sure I could point to a book that I've still got somewhere. But you know, if you were doing a PhD in computer science in 1990, if you did persistent object systems, you're good. And the concept was basically to eliminate the mismatch between the objects that you're using in your program and the objects that you store on the disk. Because normally there's a step there where you have to convert your objects into a serial byte stream and put that in a file, or reverse that process and pull it back out of the file and make objects back out of it. With a persistent object system, you don't do that. You just tell your object to be persistent, and it just is. And the system takes care of kind of swapping those in and out of the storage. So one aspect is it's more convenient. But the other thing is, because everybody agrees on what the storage is, it means programs can actually connect to each other's objects, which ordinarily, if you've ever tried to open a WordPerfect file in Word or something, programs using each other's storage formats doesn't really work great. And of course, still doesn't necessarily work, but it's a lot easier to say, my calendar is putting objects in the storage system, here's what they look like, and then some other program can just look at them and just know what it's looking at. So again, just saves a huge amount of mismatch between things. And it also saves a lot of space, which is important on a tiny, tiny computer, which Newtons were. Nobody has to write all that code to do all that serialization and deserialization and communication, because it's just built in. It just works. So that is another one of these ideas that kind of, it started out as just a bunch of research reading, and then it kind of percolated, and then it just kind of came out later that way. In the early Newtons, the idea was we actually had very tight integration between the operating system and the language runtime. And the virtual memory system would actually know about the language objects, which is the way the cool people at MIT did it. But that didn't really happen, although it did sort of happen, because when you have a package and you load an application package, there actually is basically a virtual memory system that's paging in those objects and decompressing them. So it does know a little bit about it. But that kind of, it's kind of like the Dylan, we knew we wanted to have a dynamic language to program the apps in, and we got one, just not the one that we thought. So we always knew we wanted a persistent object system. We just didn't get the one that we thought we were going to get.
Exactly.
But there's aspects of that, like today you would have completely different thought process, because like there is no security on a Newton. So the whole concept of, I can just load an object from somewhere and it can have code in it and override stuff and start executing. Nowadays that's insane.
We were so naive. There was no notion that this would ever get hacked for misuse.
But because apparently there weren't any bad people then, people did really cool stuff with it, because you could have a calendar object that would load and it would actually have code in it. And you could send an email with a button, and you push the button and it would do things, which is a great idea if you can trust the person who's sending you the email. Those days are gone.
Yeah, those old days. Miss them too. Yeah, Newtons, they are highly intelligent. Like, the ability just to like mindlessly share data with stuff is just it's smart. Like
Well,
how
actually,
you can
as,
just have one set of data for a bunch of applications that's just like effortlessly shared between them. If only if that was still existed, was still used today, my phone would not be running out of storage. Heh.
Hmm. Good point.
well, probably would be with all the video is the problem, but
Not really videos, but almost 50,000 photos.
oh, that'll do
Memes
it too.
and stuff.
As Matthias was saying, also, it isn't just that the store is shared, but there aren't actually separate applications in a Newton. There's only one application running,
Yeah.
uh, and when you open a
It's
package,
packages. That's what I
not,
meant. Sorry.
it's not running a separate process like a Mac would do. It's just it's already there. It's just showing it on the screen.
Yeah.
So you can reach into another application and insert some UI if you feel like it.
Yeah,
And
that is
you can do that.
intelligent.
You can do that because everyone's using the same UI tools. It's exactly the same framework for all the apps, so you know what you're
Well,
going to get into the other app. So it's a very weird environment for today.
yeah, if
Whoever used
only
like a this machine or something like that, or
if
small.
only newer devices were this easy like to transfer data with, because Newton's just they're so smart and ahead of their time.
Technomancer. I'm gonna just give
Mute
a
me?
couple people have their hands up, so I'm just gonna let them
I'll mute
go.
myself. Okay. There you go.
I don't mind the questions. I'm just gonna put somebody else on for a little bit.
Okay, I'm chill with that.
But
I
thank
was
you
done
for your question.
anyways.
Yeah, that was good. Those were good comments, actually. Very
Okay,
good.
I'll go mute myself now.
Okay, Chris R. from Montreal.
Yes,
Bonjour.
hi. Yes, hi, bonjour. I was just curious. I have two questions, if you don't mind. The first one is in regards, at the time of the Newton was being developed, Apple was in an interesting situation where they were supporting the Newton project, but they're also heavily invested with General Magic and Andy Hertzfeld and all his features. Was there any discussion, because they went through many of the same types of discovery processes of which you've just alluded to, programming languages, inventing everything, inventing USB, inventing all the various things that were required at the time. I was curious if you had any, both parties were both very secretive, both parties, however, Apple was the common link between both of them because they were heavily invested in both. Can you talk to a little bit about how that was integrated, or whether any of that showed up in your frame of mind?
Let's let James start because he was paying more attention to that than I was.
Well, I'll start, but Walter, you should definitely chime in. But I guess my 2 cents is that there was deep connective tissue between the Newton team and what became General Magic, because a lot of them were on the founding Macintosh team together. And it was almost like we had like 50% of the Mac team on Newton and 50% over, not 50%, but of some of the founding fathers. That project was originally codenamed Pocket Crystal, if I remember correctly, and became a separate company that spun out of Apple. I think early on, there was a mistaken belief that General Magic was going to solve an open networking standard for agents called Telescript. And remember, this is before the internet. So there was this idea, the really, really big idea, that you could have these intelligent agents running across geographies and across companies on this network, and AT&T would run the network and General Magic would build this thing called Telescript, whereas Newton was off building what's after the computer. What is this new personal digital assistant? More of a man-machine device challenge versus this programmable network agent thing. And then of course over time the two things just had more of a head-on collision.
Well, it's interesting that I think if you step way back, Newton started as a standalone device, and as I recall, about 2 months before it shipped, someone said, "Oh no, it's actually all about communication." So it kind of extended itself onto having connections to the fax and the phone, the network, and so on. But it was primarily just a solipsistic kind of device. Whereas General Magic was sort of the opposite, because we want to have these network agents, but how are you going to control them? You're going to need a new device to control them with. So kind of starting from a different angle, but ending up building both things, sort of. we never got telescript. No one ever really got telescript, to be frank, but just different priorities and how you were kind of envisioning the output. And that, your point about the Mac team, I should have mentioned that when I showed up as an intern, it was crazy because I was a total Mac fanboy I bought a Mac in January 1984, and just showing up, it's like, oh, it's Steve Capps, it's Larry Kenyon, it's
Jerome Coonan, Steve Sakovic.
Right. And just, it was like going to work with the Beatles or something. It was insane. And I think that, they all had, I know now, having lived through Newton, how they felt having lived through the Mac is it's like a war, like you will never forget the friendships that you made during that period. So that, I think you're right that they were always in communication, even though, officially it became a spin-out company that had nothing to do with anything Apple was doing. And it was a sort of a weird corporate situation, but as a personal situation, everybody's still talking to everybody. But again, just very different approaches and very different stakeholders, and it just came out to a different place.
Thank you. If I may, just at the second part of the question, you've touched on just one person I was curious to know about. So Steve Sackman was a big fan of the Hobbit processor, and of course, when the Hobbit was switched out at the Newton, he and Jean-Louis, I don't know the timeline exactly, maybe you can clarify, left afterwards and started their journey together with the B operating system and what ended up being B-Box and all that stuff.
Yeah.
But so how, Steve was an integral part, as far as I remember anyways, to the initial hardware platform. But I don't know how that switched out after the Hobbit was switched to the ARM processor. I mean, is that about right, my timeline recollection?
Well, when I arrived, there were like four or five hardware people, and they were along the way of building the initial version of the hardware, which was with the CRISP, which was the AT&T chip that existed at the time. And it was, like I say, mainly because of it's the only was the only low power RISC processor at the time. And it, they had to have a new version of it, which was the Hobbit. So they started working with AT&T to build that. For various reasons, the business relationship with AT&T did not work out, and they needed another processor. There actually was already an ARM processor in the hardware because it was controlling the LAN, the IR LAN, right? And it was a little ARM, because ARMs are embedded processors. They're used all over the place in very, very small things. So. But they had, I guess the hardware people had learned about the ARM from it being in that role and said, this processor is pretty cool. Couldn't we just use that? And it caused this crazy thing, which is this joint venture that Apple and Acorn, which was the originator of the ARM, and Olivetti got together and each funded a third of this new company called ARM Limited, which is now this giant behemoth company that sells more CPU designs than anybody. But it started as a way to have a new version of the ARM chip and have a reliable source for it for the Newton project, which is crazy. But that's another thing where it's an outgrowth of a direction that just it took on its own life. It didn't depend on Newton anymore after that. So the hardware went through many generations, just like the software did, and that was one of the early decisions. After that point, all the hardware had ARMs of various kinds in it. I'm not sure I'm answering your question, but that was the sequence of events processor wise anyway.
Thank you very much for your time.
Yeah.
Jason, you're next. What's up?
Okay, question.
Oh, there you are. Okay.
Yeah. I was wondering, like, just hearing about how soups work and what components are in them and stuff. I was wondering what the connection would be, if there is any, from soups to, say, graph databases.
Well, there's a lot in common in terms of the data structure, because it's basically a graph data structure. It's got a thing with name slots, and they point to other things. The two big differences would be probably the units of storage. So when you store something in a soup, it's got a very well defined boundary around it. So you can't point between objects in the soup. You can have objects that point to each other, but that entire little mini graph is serialized as a unit, as an object in the soup, or whatever it's called, an entry in the soup. Can't believe I remember that. So it's safe because when you pull it back, you're not going to pull back the entire soup accidentally, right? It's unsafe in that you can accidentally try to write the entire world to the soup, which is one of the failure modes in Newton programming. But it has sort of circuit breakers that if you try to refer to a ROM object, it knows not to follow that because that's insane. So it tries to protect you from yourself a little bit. So that's one thing. The other thing is the way you query it is very different because Newton doesn't really have a query language. It didn't really have room for one, and I didn't really have enough time or brain cells left. So it really, when you query a soup, it's kind of like the level below the level you should have. In a regular database, you have a bunch of indexes, and you write a query in a high-level language, and it figures out which indexes would be appropriate and what tests to run and what order to look at things. That sort of happens magically in something like a SQL database or a real graph database. In the Newton, you just say, I think you should use this index and in this order and run this test. So you have to think all that through and figure out the optimal way to do it. And that's sad, but it was a very small product. But it was done that way so that at some point you could put the higher level on and it could become more clever and figure out the thing to do. It just never got that far. Nowadays you have things like MapReduce and totally different ways of querying something like CouchDB is probably the closest thing we have now that's a real thing to what soups are. So they call them a document database now. So each entry in a soup is basically a little document. That's what you would call it today.
Great, thanks.
Very cool. Before Simon, there's one text question here that says, Walter, how satisfied are you with how Newtonscript turned out? Is there anything you should have changed in retrospect?
It's a little late to be asking that now. But yeah, I think it actually came out pretty well, but like I say, I would not have gone with the Pascal syntax if I was doing it again, because that was a dead end. It turns out C syntax is what people want, just like at JavaScript. And it was clunky, some of the, like call with, very clunky statement. And it's because our parser was not very good and we were in a hurry. So using a little more intelligence on the front end, language syntax would be good. I think there was some clunky stuff in the object model, like binaries having class slots just confused the heck out of everybody. And I think giving them proto slots might have worked better. So they would actually have methods, but who can say? But I think it's like 80% good. I mean, there's a lot of rough edges here and there, but conceptually it came out pretty good. It would all be just little details that I couldn't have known back then. Just from experience now, I would probably just smooth things out. And also maybe giving people a debugger would be a good idea. Not technically part of the language. That inspector that you saw isn't really it's a cool because a lot of things don't have that because they're not dynamic languages and they can't just run code that you type in. Like iOS doesn't do that. But not having the ability to kind of stop and step through source code is very clunky. We did have somebody who came on, and I'm not going to remember his name because that was a very long time ago, but he was awesome, who sort of joined the Newtonscript team and basically wrote the debugger. And it was a text-based debugger that you used through the inspector, but having it was fantastic because then you could actually set a breakpoint and see what was going on as opposed to just printing stuff and hoping. So prioritizing that tool would have been probably a good idea, and being able to do that well would have required a few changes in the language, I think.
Good. So Simon Bell, if this is the Simon Bell I'm thinking of, this is the Simon Bell creator of several Newton products.
Yes.
Go ahead.
Thank you. Following on from the comments about the debugger, I was wanting to talk about the Newton toolkit, and I was interested that some of the elements of the text editor in the toolkit rely on Newtonscript, and I wondered if there was any ever an idea to develop the entire Newton toolkit in Newtonscript itself, as has happened in other languages.
Right, you can write editor commands in Newtonscript, right?
Yeah.
Yeah, which is a little crazy. My original idea was exactly that the Newton toolkit would be based very heavily on Newtonscript. And it would essentially, so the way I was thinking about it before it got built was you would have the Newtonscript runtime, you would have a different UI framework because it would be a Mac UI framework, but similar. Because that's the way you build the Smalltalk environment or a Lisp environment, is you build it in the thing. But the guys who built it used Mac app, which was probably a very smart thing to do because then they didn't have to build the UI framework part. But it meant that they had to duplicate a lot of things also. So it does have a Newtonscript runtime in it because it has to be able to compile things, and they took advantage of that by letting you do things like extend the editor in it. But they also had to basically build a shadow world of Object Pascal objects that are like the Newton data model. So the stuff you're manipulating in the browser is Pascal stuff. That's their own universe. And then they sort of translate that into Newtonscript when they're compiling it. So it's kind of a weird hybrid. I think it would have been really cool if it had just been built in Newtonscript, but of course it would have been a year later, so that would have been maybe not so great.
Right.
But it is great. I think it is very cool that they got the editor extensions in there.
Yeah.
Good. Okay, so
Thank
we have
you.
another text message here. Where did it go? Sorry, I lost it. But it was basically, oh yeah. What do you think of modern languages like JavaScript, Python, and Lua? Do you appreciate or envy JavaScript's success?
Wow. I don't really have envy. Would be, I don't know how I would have envy for that. I don't associate envy with language design. That's not a, anyway. I think so. JavaScript is an interesting example where I think what happened to JavaScript is what we were hoping would happen to Newton, which is the platform it's embedded in became so incredibly popular that it couldn't help becoming popular. So it doesn't matter what JavaScript is like. The fact that it's how you extend the web browser means it wins. So we're just lucky that in the 2 weeks or however long Brandon had to build that thing, he was smart enough and knowledgeable enough that it came out as good as it did. I think that there's if you look at kind of modern JavaScript, it's got enough layers on top of it, like enough that down below it still has to be compatible, but there's been enough stuff on top of it that a lot of the issues have been addressed. Like if you use TypeScript or some kind of higher level compiler or transpiler, you can do pretty well. I think that there's other languages that are interesting. Like I'm in the middle of learning Rust right now, that are a lot more kind of focused, like they have a purpose and they're taking their time about working on the definition and getting it to be very refined. I mean, they're doing it all in the open, and it takes a long time, and it causes compatibility problems. But they're just they're explicit about saying this is going to take 10 years because this is a real language, and there's some really interesting stuff being done like that. Go is another example where they had actually, again, it didn't quite come out with the audience that they thought it would, but but they had explicit goals, and they're smart people, and they said this is going to take a long time. We're going to do this right, and it's there's a whole new generation of languages like that in the last 10 or 15 years that I think are really exciting because they're not just hobbies, you know. That's the wrong word, but they have serious backing, and they have a serious goal, and they have a big audience, and people are really using to do the real things, and they're also distinguishable. Like they have different goals. So I think if you come back in 5 years, or even today, really depending on what you're doing, you're going to have a great selection of really great languages that are much more modern than what you would have had 10 years ago, and you'll have this great toolbox to choose from. And it's also it just, well, to some extent it kind of counteracts the tendency that we keep building these stacks of things, and it's becoming impossible to know how anything works. And so it really is important to keep that focus, so you can narrow your scope. And like, this is a language for system programming. What do I have to learn to do system programming? It matches what the language does. You can kind of live in that world. Then you say, I need to write a web application. How does that work? And it's a different world that you can learn about, as opposed to sort of everything going in the same bucket. And, you know, there's just too much to learn to be able to do anything. I think that the language, the way a language works is one of the main ways that you learn how anything around it works. You know, if you try to do iOS programming, you're going to learn Swift, and then, as they're not quite to this point, but as the toolbox is written in Swift, it makes it easier to learn the toolbox, and the toolbox uses features of Swift to do what it does, and it becomes a sort of a circle. So similar to the way Newtonscript and the Newton toolbox worked together, you know, Swift and the iOS toolbox work together, the web browser and JavaScript work together. That's the thing that I like probably the best about the current universe, as opposed to back when everything was C, and no matter what you were doing, it was going to be in C, and you had to learn just stacks and stacks of conventions, and there's no connection between the language and what you were doing. so you had to keep all of this stuff in your head. The language didn't help you at all. And so JavaScript was kind of one of the early ones of that, but it's, you know, it was it didn't really do that, but it's gotten there. And then these newer ones are very, very much like that. So I listed the languages just randomly to answer your original question that are interesting. You know, Go, I think, has had a fascinating path, and obviously is completely established, and you'll be writing Go for a long time. It's basically what the cloud runs on. If you're writing a network server, you're going to do that. I'm really excited to see Rust taking over from C++ very slowly but surely. Like, I was just talking to people at Microsoft who are using C++ to write, you know, drivers in Windows, and they're really excited about it because that has really needed some help for a long time. And I think there's things like TypeScript that they're technically JavaScript, but they're not literally JavaScript. It's great that people can build that. Like, there's enough knowledge around that you can sort of fix JavaScript and have it become something that uses kind of modern concepts, but it still works on the web. It's still useful. So those are probably my current favorites. I do think Lua is awesome. I've used a lot of Lua. It's, for what it does, that's a great example of something that's just a very small, like, kernel of somehow it's selected exactly the right things for what it does, and it's going to be around forever too, you know, just because it is what it is. Like, it's everywhere. That's a good enough list. There's other ones, but Haskell is really cool. Don't try to use it like in real life unless you have other friends that you're working with who want to use it, but do learn it.
Cool. Ronnie, what's your question?
Yeah, my question was just from really building on what Walter was talking about, because I've heard that C# is being pushed as an alternative to Swift, as a sort of cross-platform language with something called Blazor. I just wonder how you would position that based on what you just said.
Well, there's also gosh, he's from Mexico, so I guess it's Xamarin, or Xamarin, as everyone calls it around here, which is a cross-platform .NET framework. I think there's definitely a place for that, which is especially if you want to do a cross-platform library, like you have some logic that you need to run everywhere. There's not many things you can do that in. You know, like you write your code and you want it to run on iOS and Android and your server and your Mac and your Windows machine. It's really C++ is kind of your only choice, unless you go to something like Java or you can do it in C# now. Swift is moving the other direction. They're doing pretty well on not iOS or Mac. So I think those are all viable choices. I think it comes down to how long do you believe the support is going to be there, and obviously C#, now that Microsoft bought the cross-platform company, seems to think that it's a cross-platform language. You know, .NET Core now is totally cross-platform. And also, how much experience do you have? Like, what ecosystem do you want to live in? Because those are the most important things when you're trying to do a long-term project. So I think all those things are viable now. So if you prefer C#, or, you know, the great thing about .NET is you can use F#, you can use several different languages. Then that's great, and I think that'll be around for a long time. Swift, I think, is a different attitude. You know, it's native compiled, and it just feels different. It's because it's derived from Objective C a lot. So even though it does have a lot of static typing, strong typing influence, it also has a very dynamic part to it because of having to call back into Objective C stuff. So a little different feel. So there's a matter of taste involved too, I guess.
And Walter, I'll quickly chime in and say Google has this interesting effort with the Dart language and the Flutter framework, where you can code once and compile natively for both iOS and Android. And they claim they want to continue to expand other target platforms, including desktop apps and web.
Yeah, Dart is not quite as far ahead, but it's definitely interesting. And then there's also, you know, React Native keeps coming back. I don't know how it gets better. And I probably wouldn't pick it right now today for something, but keep an eye on it if you want to use JavaScript.
Cool. Thanks, guys. There's just one or two more technical questions, and then I have a question for you both. Were the various global functions of Newtonscript decided upon following a process, or were they just made up on the spot?
Was anything in Newton done following a process? Not usually. Yeah, so mainly what would happen is either it was a kind of I don't know, like a fundamental thing, like add array slot, and I would just do it. So I would just tell people, hey, there's a function called add array slot, enjoy. But if it was more of a framework thing, like get root, then Caps would probably do it. And I think it's just another one of those things that it just grew over time, because as people started doing more and more things in, you know, writing more applications or more of their application in Newtonscript, things would be missing and somebody would create the thing, and eventually we kind of understood how the namespace would work, and we really never made another namespace than globals. You know, so we tried to make it hierarchical sometimes, so we didn't just cram everything in the top level. But you know, that's a lot of stuff just ended up there. I think if you went back, you would probably restructure that to some degree. But we also, remember, came from the Mac toolbox, and everything's a global function in the Mac toolbox. So it seemed kind of normal at the time. You know, the Mac toolbox is just header files that have 850 functions in them, and they just have prefixes. So it's kind of similar on Newton.
Mike and Matthias, I saw your hands go up briefly. Did you have questions? No? Um,
I was sorry. I was briefly mentioned the single stepping and debugging of Newtonscript through NTK, and I wonder. I thought I saw some stubs when I was looking at the hex dump that it was started to be implemented, but I couldn't find out how it works or if it works at all, or was I just mistaken there?
The actual debugger is a package that you have to load,
Oh, okay.
and there's a hook. I still can't believe I remember this. There's a hook in the interpreter for breakpoints, so you can basically tell the interpreter, I think maybe one breakpoint. Anyway, a very small number of breakpoints. And if there are any set, then when it runs across that bytecode, it will stop and tell the debugger to run.
All right.
So the debugger itself is just a package that you load that hooks into that thing. And I don't think NTK knows anything about it. I think it was really just you use it through the inspector, if I recall correctly. It adds like a breakpoint command and a single step command.
Oh, yeah, that could well be. Oh, thanks.
Like I say, we never got as far as actually showing your source code or anything.
Well,
it's more like a Lisp debugger from 1975.
Yeah. But we can still work on it.
Absolutely. Please feel free. There's one other question in the chat, I see.
Sure, go ahead.
How does compiling Newtonscript to native code work? This is two questions. Was just-in-time compilation ever considered? While the native Newtonscript, hopefully James will remember the history of native Newtonscript, if he's still here. Oh, he has a phone call. So we had these developer kitchens, as James was talking about, and one thing people notice is Newtonscript's kind of slow, and especially it was really slow in the early Newtons with the 20 megahertz processor. And there was nothing I could do about that because it's in ROM. And I made the interpreter like 2 or 3 times as faster in the 2.0 ROM, but still, it's not that fast. So I thought, well, people need to write native code, but you can't just let people write C code because then we can't keep it compatible when we release a new ROM version. The great thing about Newtonscript is because it's all bytecode, you reinterpret it constantly. So if you run it on a new ROM, it interprets it differently so that it's still compatible. So the idea was we would have, and we stole this from the Mac, where when they did the PowerPC to Intel transition and the 68K to PowerPC, you can make a fat binary, so you can have the native code for both platforms in one file. So I said, well, the bytecode objects will be fat binaries. We'll have one that's the compiled code, native code, and another that's still the bytecode. So you can reinterpret that if you decide the native code is not going to work. So that was a great idea, but then there's no compiler. So I spent quite a long time trying to write a native compiler and learned quite a lot in the process and just ran out of time. And I realized I could just, instead of coming out with object code, I could come out with C, like a really oversimplified C code that just looks like intermediate code in a compiler, and just hand that to the RMC compiler, which I could just link in as a library into my compiler, which is part of NTK, which is ridiculous, but it worked. Because thank goodness they had written the RMC compiler to basically have one entry point that the command line would call to tell it all the flags and arguments. So I just called that entry point. So inside NTK, if you look in there, there's all this C code that's sort of this header and footer that it puts around the stuff that it compiles to be the function. And when it compiles a native Newtonscript function, it actually literally translates it to C, sticks it in the middle of that template, and hands it to a C compiler, and then deconstructs the object code that comes out and sticks it in a binary object. So there has to be a lot of glue and stuff to make that work, but that's how it works. Which is crazy, but it did work. And the reason I was hoping James is still here is we went to a Newton Developer Conference, and we knew people were going to ask about this because it was a very hot topic. Anytime you talk to a developer, they'd be like, are you making Newtonscript faster at some point? So I had just barely gotten this thing working using this maze generator game that somebody had written, which had a very slow inner loop because it was doing all this work. It's just data structures. So James said, can we demo this at the developer conference? Like the day before the developer conference. And I said, sure, okay. So during lunch at one of the conference days, I got up on stage and I literally had my hard drive from my computer at the office. So I was looking at it to make sure there was nothing confidential showing on the desktop anywhere. And I just launched into this demo using random, my random build from today, hoping this was going to work. And it did work, thank goodness. It was a little goofy because I had to copy and paste the object code from my tool into NTK because it wasn't integrated into NTK yet. But the demo went okay. The maze went like 10 times faster. The people who knew about it and showed up in the audience were suitably impressed. And then that kind of took a lot of pressure off because people thought, okay, we're getting a native compiler. This is going to be fine. Which is one of my favorite Newton stories, but just because of the stress. So on just-in-time compilation, that was really interesting because no, it doesn't do just-in-time compilation. When I was doing it, self did do JIT compilation because it's the only possible way you can get self to run at less than glacial speed. But they were the first people to do that, as far as I know, and we all thought they were insane. So, I mean, thank goodness you work at a university and you can get away with crazy stuff like that. And that's also super cool. Nice job. But there's no possible way I can use that. And of course now, it's everywhere. But one of the things you have to have is a very fast processor to compile stuff and a lot of memory to keep the compiled code around. And Newton had neither of those things until much later. So I think around, message pad 2100, with a glorious 4 megabytes of RAM, we could have had a better garbage collector and we could have tried doing some JIT compilation, but we never got to that. So no, it doesn't. I did think about it, but no. I was looking at the Doug Menuas exhibit and I found this one picture that it's in the book if you get to find graffiti book.
Nice.
And this is a fond memory. So you saw in Noah's video the inside of this guest house.
Yeah, this is funny.
And so my girlfriend at the time lived in that guest house. She's my wife now. And I ended up basically moving into that guest house because I was talking so much with Caps all the time. And neither of us felt like we had time to drive to the office because it was just so intense. And so we eventually just gravitated to where we were just both living in Caps's little compound there with his house and this guest house. And now this seems normal, right? Because everybody works, literally right now, everybody works at home, right? But back then that was not normal. That was really hard to do. And so we had Apple put a dedicated 56 kilobit line between the office and Caps's house and put adapters to either side to turn it into TCP, maybe not, AppleTalk maybe. And this is Caps running an Ethernet cable between his main house and the guest house so that I can get to that leased line. So the whole arrangement was just crazy because I would basically go home to take care of the cats like a couple hours a day. Other than that, I just lived in this guest house for weeks. And it was just a nonstop experience. And I remember the code for the object store, I had borrowed the B-tree code from some other place at Apple. I think it was from the source control system in NPW. And it was not good code. And I didn't know that because I thought I'll save time by using code from somebody else that works. It didn't work. So I would run my test code and go to sleep, and then I would wake up in the morning and just look at all the failures and just start working through all the failures. And then I would go to sleep again and let it run again. It was just weeks of that. So that's what this reminds me of whenever I see this picture.
Walter, we have two other people with questions. So Mike, if you could ask your question.
Well, actually, it wasn't so much a question for Walter. Not that I don't find this interesting. This is just amazing. It was actually for James, but since he's not there, I just want to take an opportunity to show Sir Isaac the T-shirt that I still kept. It's still brand new from the Newton stores. I'll just bring this up. Do you guys see that?
Yeah.
That's mine.
Yes.
Yeah, I still kept.
That
It's
is
brand new.
awesome.
I never wore it. I had 3. One I gave to a girlfriend at the time because I thought it was cool. One I wore for myself, and one I put away in storage. So because you guys had created, for me, it was the Hitchhiker's Guide to the Galaxy device of the time. If people are not, familiar with that, look it up, Douglas Adams and whatnot. It was the device to end all devices for me. So I just want to say thank you so much. Thank you.
Well, thank you, Mike.
Hey, oh, my pleasure.
All right. Okay. So we have another question from Forrest. Forrest, are you with us?
There we go. There we go. Okay. Hey, Walter, as I said, I could listen to you talk all day. I had a question for you about something that's always bothered me. In Noah's film, you showed us a lot of prototypes of Newtons, a lot of different Newtons from other companies. I think there was one, I know there was one for the healthcare industry, and there were some other things that were going on with that. And I know Sharp had something. There was, I think Grant has a lot of that kind of stuff too. I was curious, obviously when the Newton ended, that pretty much ended those projects as well. But yet there seems like there were so many of them. I'm curious, is it because Apple didn't release the proprietary information for those? It just seems like somebody would have picked up on that and would have gone on, since it was such a market apparently for those. It just seems like somebody would have picked up on that and gone on with it, and created their own devices, unless it was just a case of Apple not releasing the code for that.
Well, those devices existed because Apple licensed the code and the hardware in a lot of cases to those companies to build those things, and that's actually was the basis of the spin out. Apple spun the Newton Group out as a whole separate company,
right?
And the business plan of that company was to license that stuff out to more and more people, and so that it would have been kind of its own. It's like the PC industry, it would have been lots of different kinds of Newton hardware. So that was the theory, but then that got killed. So then there were no licenses anymore. So nobody could build anything out of it. So all of those projects had to shut down.
It just seems interesting. You would think that since business doesn't exist in a vacuum, you would think that somebody would have said, hey, this is such a good project. Can we somehow create our own parallel project based on it? I guess based on what you've told us, there's way too much development involved in that to try to even create something similar to the Newton, because it was just would have been too difficult. Is that your understanding?
A lot of small computing devices, were created. It's just they didn't literally use the Newton technology. They kind of had to start over. And I think probably if somebody had come up with a big enough number, Apple would have sold the technology to somebody to go do it, but no one was excited enough to take that big a risk on it, presumably.
Okay, thank you.
Adam Tao, did you have a question?
Actually, it was after we kind of exhaust our questions with Walter, I just wanted to maybe get some help from the community to try to get some of these apps to open up in Newton Toolkit. I've been going through my source code. I found a bunch of them that do open, but some of my more complex ones haven't. So I'm trying to figure out what could be the problem. I'm sure our collective minds could figure it out. Or if I send the source code somewhere, someone could open it by tomorrow.
Good. Have a new toolkit workshop after this.
Adam, sorry, can I just hook into that? Adam, did you set the memory higher on Basilisk? Because the standard default setting is something like...
I did. So let me share my screen real quick. Share the whole screen. You can see it now. So I have Basilisk, that's a little too big, up to like that. Seems like a...
Oh yeah, okay.
Number. And so it runs... I even up the memory for like Newton Toolkit.
Mm-hmm.
So if we look here, like 2040.
Oh yeah. Mm.
And then even in here, I set like the toolkit preferences to be nice and
Yeah.
big.
Yeah.
So if I go to a project, if I go to like something simple, and you can see my whole screen. So this one. So something like small one works fine.
Okay.
Show you this real quick. Seems to open up fine, but if I try to open up a larger project, say go to this one, it just hangs. Sometimes it like shows the loading screen, or does that.
Oh, error type 25. We can look that up.
But sometimes it just hangs. So
Yeah.
I don't know if it's like a resource fork thing because other files seem to open up, or like it's some of the things got maybe munged.
Is it on, which disk is it on? I had a problem when I left it on the Unix disk and applications wouldn't open up.
Okay, it is on the Unix disk, so you recommend just moving it to like Mac OS disk?
Yeah, you have to unpack it on the Mac OS disk.
Right, that's probably the, yeah. I don't think the Unix one has the resource fork.
Yeah.
That makes total sense.
So you have to put it packed onto a Mac OS disk and then unpack it on the Mac OS disk. If you unpack it on the Unix disk, all the resource forks are gone.
So when you say pack, should I do that on the Mac side, like Mac OS 10 side, zip it up? Or
just put, if you can, do it all in Classic.
Okay. So, man, it's been so long since I've done this. How would I pack it up?
The issue is
I would just try it. Just try copying it. Just try copying it over, because sometimes I don't know that the Unix drive doesn't have the resource forks, or maybe Sheepshaver. I've successfully gotten files across and maintained their file types.
Yeah, Unix does. Mac OS, if the host is Mac OS, it does have the resource forks, but Basilisk doesn't transfer them correctly. The problem is the interface between Basilisk and
Aha. That looks like it might work. Undefined
Adam,
function.
this is why I needed to use Sheepshaver.
Okay.
For my own source code. I had to get to archive in Sheepshaver with macOS 9 with the proper compressor, and then recompress it there to put in then back into Basilisk, because Basilisk is macOS 7.55, and you probably use macOS 9 to make your archives at that time.
That might be right. Yeah.
That might be it. I know that if you follow some of you know, the instructions, like I was copying my source code off using the Unix drive and then using split forks to split the forks into separate files for checking into GitHub. And so that process involved using the Unix drive, but it also proved that the forks do translate across the Unix drive. But I may have been using Sheepshaver, not Basilisk.
Mm-hmm. Is there a possibility to get Basilisk to run OS 9?
I think it stops at 8.5. It uses the Motorola 68K.
Okay. And does Sheepshaver work? Like, does it work now, or is it broken?
No, it works. I ran it yesterday. I compiled some apps. You'll see them tomorrow.
Okay. Maybe I'll see if I can get that up and running.
It doesn't have the TCP interface to Einstein, though.
Yeah, that's true.
But I can just drag the shared files.
Sure.
Does it do like shared directory?
Yeah, it's a Unix mount, just like this.
Yeah. So then I'll just copy it to Basilisk and copy the files over then.
Yeah.
Okay. Looks something to do tonight.
So I'm wondering about the do you remember the old there were API calls hidden on the Newton to change the number of clipboards and to change the undo behavior, And there was sort of speculation why this wasn't exposed anywhere in the user interface, but it was just, an API call that there were third-party extensions that would call. Do you know if that was a memory thing or a, just difficult to describe to users and they didn't want to, have to describe it in the manual? I always just kind of was wondering because it seemed to work just fine, but it wasn't accessible unless you had a third-party extension that called that API call.
I dimly recall that at some point you could drag more than one thing to the edge of the screen and they would stay there. But maybe that was just confusing.
Well, so there was a call that you could use. There was like a global call that would let you change that, but no UI to do it.
I have no idea exactly why, but I suspect it's just because people didn't know what was happening. Technically, it's just saving a pointer to the object, so have as many as you want. But it's like it must be a UI thing.
Yeah, I was just that was a speculation. I was just curious. Do you remember the documentation for the missing global function is halting?
It sounds like an Easter egg to me.
The funny thing is that every so often on the Newton Usenet group, you could basically tell who'd had a formal CS education, who hadn't, because people would be like, "It's not there. Why? I tried to use it." I mean, nothing against lack of formal education. It's just that in the real world, you probably wouldn't encounter it.
There actually is an Easter egg in Newtonscript itself, which I can't remember exactly what it was, but it's something like there's a string function. It's like substring or something. And if you call it with some outrageous arguments that you would never do by accident, it returns a string. And I don't know what the arguments are, or what the string is, or what the function is, but I do remember getting in trouble for putting that in because I did it too late. If you're going to put an Easter egg in, you have to do it earlier before everybody's looking at every code change. So Larry Kenyon called and yelled at me. But we left it.
Remember what it is. Be fair.
Guys, we have two hands up. So Frank first, please. Frank, you need to unmute yourself. Yes.
Sorry about that. Can you hear me now?
Yes.
Okay, I have more than one question, and it's directed to the people from the former Newton team. I don't know exactly who I direct that to. And tell me to keep my big mouth shut if it's not a proper question or an appropriate question. The first question is, there is a PCM-CIA card, it's known by the name of KDIX card, something like that, that allows you to do interesting hardware tests with an image. For example, you can like rewrite the bottom part of the flash RAM, which normally isn't possible, and which sometimes is the home of an ugly bug that doesn't allow the battery to be charged anymore. Is such a card, do you know if such a card was available for other Newton models too?
Well, I mean, there are all kinds of crazy test tools internally, and the factory had the official tools, and those varied by model, and I have no visibility into those because I didn't work with the factory on stuff. But I suspect that's what that is. It's for the factory trying to diagnose machines that come back, or it's for hardware developers working on a prototype. So those, if it's for the factory, they would have made a bunch of them. If it was internal, they would have just made them as they needed them. So who knows? But they definitely they existed. Probably for any given model, there would be things like that. And there's also in the ROM, there's a test mode in the ROM a lot of times if you start it up in a weird way.
Well, actually, I figured that test mode out for only one model, the 130 model. But there probably was test modes, but I just wasn't able to figure them out. But I have two other questions. You have probably heard them a million times by now. Do you know there's a chance to get schematics for the Newton model hardware? Probably not, right?
Well, as I was saying earlier, I know something about the source code because that's what I worked on. So I know that that got archived somewhere. So that probably exists. I don't know what happened to the hardware information. I mean, I would think that it also got archived somewhere, but I didn't see that happening. I know that they were very serious about archiving the software because of some incidents, but the hardware, you know, I would have archived it, but I just don't know. So it could be stuck in a file somewhere. The hardware folks, you know, they had these big Sun workstations, and they used early hardware CAD stuff to do the PCBs and the schematics, the netlists, and so on. So then you'd have the problem of parsing the files if you found them. But you know, maybe they would be in some vector format. You could at least print them.
Were you software guys working physically close to the hardware guys, or was it a completely different cup of tea?
Well, the hardware designers, yeah, we're always in the same building, or you know, near each other in the building anyway. But a lot of the manufacturing stuff was not near us. But the place where the schematics came from and the ASIC designs was next to us.
Well, another thing I'm looking for, which is more on the software front, I think, is there are probably heaps and heaps of hardware things you can test by writing particular things to particular memory addresses. I found one or two of these by accident, but there must be many more. Do you think there's a chance of getting information on that?
Well, as I recall, ARMS at that point, and maybe now, didn't have a separate I/O bus like Intel processors do. So anything you do has to be a memory mapped thing. So all of the hardware registers are going to be memory accesses of some kind. And so anytime, you know, like we would get the documentation for the ASIC on the Newtons that had ASICs, and it would just be a long list of memory map of what all the registers are, what they do. So there clearly was a document at some point, and it was earlier, you know, it would have just been an informal, like an internal document. It would have just been a MacWrite file or something.
Yeah.
With a bunch of numbers in it. Later on, when it got licensed, presumably somebody wrote a formal spec for what the ASIC is. That probably exists somewhere, but I have no idea where you would find that. I mean, it would be at a licensee, or somebody who worked at a licensee might have one in their basement. I mean, who knows? But yeah, it should exist. I'm sure there are undocumented things also. Yeah, you know, like the ASIC must have a test mode, and that's probably not documented anywhere outside the factory or the hardware lab.
The reason I'm asking is because in the Newton community, I'm more or less known as the hardware guy, insofar as I want to save as many units as possible.
Yeah.
And this is why I wrote UTest, which I'm using myself all the time. It would be really great to like extend UTest for the whole Newton community, so they can do some tests on their own.
Mm-hmm. Yeah, well, I don't think I would know where to look for that. You know, I think it has to be just make a lot of noise and hope somebody hears you who saved something, because there wouldn't be any kind of official way to find that stuff anymore.
Do you consider it likely that information like this is still archived somewhere at Apple, or do they throw stuff like that out regularly?
Companies throw stuff out, but engineers don't like throwing stuff out. So I've actually talked to the Computer History Museum about, you know, this kind of thing, and a lot of their artifacts come from engineers' basements because, you know, as Grant knows, a lot of random prototypes and all kinds of crap ends up in engineers' basements, and the company doesn't know about it. And then 20 years later, the engineer is digging around in a box, and they say, "Oh, look."
Yeah.
So that's why I say it's not going to be from an official channel. Probably it's going to be somebody who just, there you go, happened to save one, and maybe they know they have it, maybe they don't even know. You know,
yeah. People
are still finding Apollo documentation from people's basement. You know, their grandchildren will find something in a box. So it's probably out there. There's a few copies somewhere, but who knows where?
Yeah, that's the problem.
Okay, so We have Stephen Frank. Stephen?
Hi, can you hear me okay?
Yes.
Walter, I have kind of a philosophical question for you. You spoke about some of the unique ideas of Newton OS, like the shared object store, packages being able to inspect and even add UI to other packages and so on. Those ideas seem like they at least are somewhat inspired by a branch of computing that begins with Xerox PARC and Doug Engelbart and Smalltalk and so on, which is a branch that seems to be kind of effectively dead. And what we have now instead are increasingly locked down devices, monolithic applications that aren't extensible, data that's kept in silos, and even platform vendors who get to veto applications that they don't want on their platform, like Einstein. So does that feel to you like we've gone backwards? You mentioned that the modern internet, raises a lot of security concerns, and a lot of these ideas aren't maybe viable in that context. But is there any way we can bridge some of those ideas back into our timeline, or are we kind of stuck on this track we're on? Or does it even matter? Does the benefit of having a worldwide, always-on internet kind of outweigh the possible loss of those ideas?
I love philosophical questions, but I tend to not put a time limit on my answers. So let me just warn you. So I think there's actually two different tensions there that never go away. One of them is the tension between flexibility and security. So it's great to have a completely open system that's you can change anything, anybody can change anything. It's like a free for all. The best idea wins kind of thing. And you're totally right that the root of all that is kind of from MIT. It's from the early hacker community, and it found its way through list machines, into Park, into Smalltalk. There's a whole kind of family tree of things that are designed to be one big happy family, and you can load software and it can change anything. Probably the most commonly used thing today is Emacs that's like that, and that is a direct descendant. It's literally from MIT of that mindset. So when you're building an environment for your editing in Emacs, you're just loading code from all over the place, and it's all running in the same thing and talking to the same objects. Same exact mentality. So, but you can also see this happening, like this whole cycle happening again with web browsers, because when JavaScript came out, everything could talk to everything. And when you loaded the script onto a page, it could see every other thing on the page. And immediately that caused malware to exist. And so they started trying to sandbox it, and it's just gotten increasingly limited. And they keep having to add more and more mechanisms because somebody will find a way around the security until you reach the point, again, of it just being siloed, sandboxed applications in the browser. And so that, I think, is just an eternal tension. It's totally dependent on the community that you're in, that's supplying the stuff you're using. If you're in a trusting community with a bunch of smart people in it, you end up with an environment that is very flexible and open, and you pick and choose things from different places, and they just all sort of more or less work together, and a lot of ideas get generated. It's a very creative environment. That doesn't scale up very far, because as soon as you let somebody into that community who can't be trusted, everybody loses at that point. But you just see that cycle repeating itself in different environments as people rediscover that. But the other tension is between, this is oversimplified, programmers and users. And this is actually one of the more powerful ideas from Park that has trouble catching on, is there shouldn't be a difference between programmers and users. So, if you have a computer, you should be modifying your computer to work the way you want it to work, and it should become your own personal environment that's optimized for what you do and the way you think and the way you work. So if you look at things like the Smalltalk environment, it's explicitly designed to enable you to do that. And they gave it to little kids, 12-year-olds, who totally caught on and were starting to program all kinds of random stuff. And the programmers themselves worked in that mode, and was very productive. And it influenced a lot of later environments, Mesa, Cedar, all those kind of Park environments. But in the real world, that tends to not work so great. You know, you give a device to somebody who doesn't really want to be a programmer, doesn't really want to customize the device. They want it optimized completely the other way. They want it to be completely reliable, one click, does the same thing every time. Behavior. So you see both of these happening in any given environment. You know, you look at the iOS environment. There's not really a concept of reprogramming your phone. I mean, you can make these Siri shortcuts and you can kind of rearrange your icons, but that's about all you can do. And it's also incredibly sandboxed. You know, everything is single function and completely one developer's universe. When you go into the Facebook universe, you don't interact with the mail universe. There's no connection between the apps. But I think that's good and bad, because that means people know exactly what to expect when they tap the Facebook icon. It's a bad example because they keep redesigning the Facebook app. They tap the mail icon, it's going to be the same every time. And that's good, you know, if that's what you want. And I have noticed just there's a whole category of people, which is a very, very large majority of people, that just want it to work the same way as it worked last time. And they have the thing that they do, and they want to do that thing and have it do what they want. And it is completely different mindset from, I don't like the way that works, I want to mess with it, or I want to connect this thing to this other thing. It's hard to get both of those in the same environment. So I think we're always going to have those two worlds, and the lockdown world is always going to be much bigger because the market for it is much bigger. So I'm just happy that the other world still does exist. And you know, it can't go away, because that's where the programmers want to live, right? And if you don't have any programmers, you don't get anything in the other world. So how's that for philosophy?
That's a good answer. Thank you very much.
I think you're muted, Pavel.
Oh, we can't hear you.
Okay, now you should hear me. My external microphone just died. The battery just died. Right, so we have a Stevie. Stevie have a question.
Yep. So first off, you know, this has been awesome. So thank you everybody for putting this together, for sticking around, and Walter for asking and answering questions and all this fun stuff. So I pulled out this old press folder I got years ago. It's from July of '93. It has some transparencies in there, so I've been scanning that in while everyone's talking. So my question for you is, theoretically, if the Newton didn't get axed and the OS evolved to, say, a version 3.0, what features would you have liked to see? Any pie in the sky stuff that never made it out there yet, that you really would have liked to see?
Well, the first one that comes to mind is maybe the internet would have been a good thing to have on there. And I don't even, I mean, it's hard to imagine what you would have done in 1997 on the Newton, because everything was changing so rapidly at that time. But clearly the internet would have been a major feature of version 3. I think there would have maybe been an app store. We actually thought of having an app store when it first launched. The problem is you would have had to dial up the app store. And we never built that, but it was definitely, you know, packages are designed to be downloaded because you're supposed to be able to dial up the app store and shop and buy an application. Thank goodness they were small, because that would have been at 9,600 baud. You know, that I think just there's obvious stuff. If you had managed to get a built-in internet connection somehow, I mean, I don't even know how physically it would work, but yeah, Ethernet card or something. There was no Wi-Fi. Anyway, yes, and then you know, open that up. There's all kinds of things you would do. I think one thing that was disappointing, and I have no idea if this is just inherently never going to work, or if it would have worked if you worked harder on it. The actual concept of applications talking to each other. I've tried that a few different times at a few different companies, and the hard part is not even the technology. The hard part is getting the application developers to agree on what they're talking about. So the only reason it worked to the extent it worked on Newton is people communicated through the system objects that Apple defined. And it was very rare for two third-party applications to decide to share a piece of data. And so that's a lot of work on the platform vendor's part, because you have to supply standard objects for everything anybody ever wants to do, which is hard. So it would have been interesting to see if that had ever really gone somewhere, you know, beyond just people sharing the calendar and stuff. And I think there's, you know, if you look what happened to the Mac, there's stuff like color would have been cool. I don't know how that would have worked. Just, you know, basic evolving the interface and the whole, just putting more memory in. There was plenty of things I wished I could have done when the thing had way more memory than it started with. Just making it faster and doing cooler things.
Ronnie, are you here?
Yes, I am. It's really two things. This is to Walter. You were saying that you were describing the lockdown world, and you were saying, so what would be the unlocked down world that you were thinking of today? What did you have in mind?
Well, like I say, Emacs is the thing I use every day that's like that. You know, the Emacs editor is just Lisp. It's a Lisp environment that happens to be a text editor. And there's tons and tons of code out there. And if you want an editor feature, you just load it and run it, and it talks to everything else. I think that you can see attempts at doing this on the web that don't necessarily always work. But people try to have an add-in infrastructure for their complicated web app. Like Gmail had this at one point. I don't even know if they have it anymore. But it's like in between, you know, it's still in a sandbox because you're in that app, but the app is extensible. I mean, I shouldn't just say Emacs. I mean, literally every text editor that a programmer uses works this way. It's just they use different extensibility mechanisms. So that's probably the most obvious example that's still like that. But it's like if you look at something like IntelliJ or, you know, Eclipse or, you know, a Java-based editor, it's a heavyweight thing. Like you have to be a serious programmer to go read all those documentation and build a Java plugin to go into your editor. Whereas something like Emacs is more of the original spirit. It's very lightweight. It's just Lisp. You can type 3 lines of code in your editor and hit go, and it's in there. So that I can't really think of a good example of that level of lightweight extensibility. You know, that's that powerful. I mean, spreadsheets are like that. You write code in spreadsheets all the time. It's just that you never really change the behavior of the spreadsheet application by doing that. But it has that dynamic of being very easy to write code in and people trading code back and forth. And actually, you know, you can see the cycle happening there too, because now you open a spreadsheet with macros in it, and the first thing you see is you should probably not run any of these macros because they're probably going to be malware. So it's a sadness.
Okay, I understand. No, because I'm familiar with things like the Microsoft world with DDE and COM, and have tried to do that between the different apps. Okay, and as you said, Eclipse was supposed to be the way in which to do that across different companies, but yeah.
There's a distinction. I mean, it's not really. It's more of a spectrum, but philosophically, to me, the question is, how deeply can you rewrite the thing using the extensibility that you were given? So, like I say, a spreadsheet is very limited. There's extensibility points that you can basically reproduce anything you can do from the UI. You can do it in code, but you can't change the recalc algorithm in the spreadsheet with your code.
No, I agree.
Whereas something like a Lisp machine or Smalltalk, or to some extent Emacs, you're totally free to do that. I remember one of the first things I did when I got a Smalltalk environment, which was on my Mac in 1988, probably 7, was I was looking at the code for menus, and I tweaked the code for menus, and now everything's broken. Like the menus in the browser don't work because that's literally the code that I was changing. There is only one piece of code for menus, and it's what all the menus use. So that was when I had this kind of aha. It's like it really is all one thing. You're under the hood rewiring the thing that you're driving, which is not the way things normally work. Usually there's a compile and a run step.
Thank you.
Jake. Whoops. Jake, you have something to say? Oops. No. Jake, your hand is up. No? Okay. Paul?
Yes, you're talking about being able to extend things, but why then the Newton, when it came out of the box, could not be programmed directly on the Newton, if I remember properly? The only exception was NewtWorks, the spreadsheets.
Well, so the Newton did not have much space, and I actually managed to get the Newtonscript compiler into the ROM, but that was kind of it was just because I felt like that might be an interesting thing to do. So it happened to fit, and so I didn't take it out, is what happened. But I thought, if I leave it in there, it'll never get updated because it's in a ROM. But whatever version of Newtonscript that is, at least you'll know that that's there, and maybe somebody will do something interesting with it. But we definitely didn't have room to put in some kind of development environment where you would actually write code, because we were definitely running out of space. But I thought, well, at least if I put the compiler in, somebody can maybe write an application that can use this. Maybe they can write a spreadsheet and they can put Newtonscript expressions in it or whatever. And so you did see things come out, like, the strangest one to me was NS Basic, where you wrote basic code that it was like, it is a development environment, but it's not even Newtonscript. So I thought that was really cool. But you see things like ViewFrame and so on that did eventually kind of take advantage of that. But that was just a whim on my part. That was never really considered part of the function of the device. And I think that was potentially just because that's the way Apple worked at the time. The Mac didn't have that either. The Apple II, I think, is the last thing that shipped with a development environment in it. And I think that was just the way it was assumed to work. You get the core functionality, and then a development environment is the thing that you put in as an application. It's not supposed to be built in.
Then don't you think that the fact that the Mac didn't come with the developer tools while the Apple II did is the first step toward the shift of the sandboxed environment everywhere?
Well, to some extent, that was because Microsoft didn't want there to be one, because there was Mac Basic that was supposed to, as I recall, was supposed to ship with the Mac. But the story I heard is Microsoft said, no, you have to use Microsoft Basic, and we need to sell that. You can't have that, or you can't have Office, or they didn't call it Office. You can't have Word and Excel. So there was some intention to at least have a standard development environment, but not in the ROM. And that's another case where the Mac ROM was 64K. It's a miracle what's in there. And so there was really no way to get literally in the box a development environment. They could have shipped a disk with a development environment, but they didn't do that for business reasons. But I think for us, it was just more not the intended usage. I mean, it was just sort of a separate, the programmer user distinction, I think, had kind of gotten built into our minds by that point, because the whole concept of everybody programs their computers was pretty much disproven by then. And so it wasn't like you're going to put that on the box and people are going to want to buy it more. It's a limited audience.
So this is what I mean. It's the first step towards a sandboxed environment where...
I wouldn't even say it was a first step. I think it was already happening, and it was just natural to not do it. I think it had already happened. That you just, it's a consumer product, and those aren't programmable. And that was just sort of already the way they were. I mean, I don't think there was a sharp point that happened, or that we caused it to happen, or were even early on in making it happen. Because by the time we were there, it was just an assumption. So it would be interesting to think of, I mean, to draw the timeline of things becoming less programmable as they kind of became more mass market. Like I think the original IBM PC was programmable, didn't it? It came with BASIC, right? So that was before. It's a whole separate conference.
Yeah, sorry, it's Ronnie here. The IBM PC was supposed to have been announced with APL.
Oh, right.
And at the very last minute, they replaced it with BASIC. And that's when they then killed off the self-programmable, because the first 5 years before, if you wanted to do programming at the weekend programming, it was APL that was processed, and the IBM PC was supposed to have delivered that out of the box, and they switched it to BASIC at the last minute, and that killed off the personal computing type revolution.
There's a lot of things about the IBM PC that diverted the personal computing revolution, but the IBM 5150, if you look that one up, was sort of the right feeling. You know, it was for people working in labs, or people who really just wanted to write their own programs. But it was you switch it on and it's running, I think, APL or maybe BASIC or maybe both. It was one of the earliest things that were like that. So I think there was definitely some history at IBM in that direction, but somebody probably decided, no, this is a business machine. It's not for scientists. So APL is not appropriate. Although there's a lot of business done in APL back then. Whatever happened to APL? It became K. I know what happened to it.
Mike wants to ask something, I think.
Yeah. Yes, I do. Walter, having worked on, I guess, the OS, the NOS from the very beginning, what are your thoughts about when the device finally reached like the 2000 or the 2100 models, which were, just fantastic in comparison to, let's say, the OMP or the 110?
Well, those were the first ones that actually started to work like they were supposed to. Because I think the software was always overly ambitious, and also put together in a hurry. Because, like I say, when I went back to the Newtonscript interpreter, I got it to go 2 or 3 times faster, just in the code. And then you add the new processor on, now it's going like 20 times faster. So I think the additional speed and additional memory in the 2000 is really when it started to be like what we thought it was going to be like. A lot fewer compromises between the hardware and the software. So it's great that the 3-digit ones are as good as they are, but you get a whole different experience on the 4-digit ones.
Exactly. Did you envisage like a whole new, how can I say, horizon with regards to all sorts of things that could be done now with this new hardware?
Well, I think a lot of the compromises could have been removed, like just low-level things like the garbage collector for Newtonscript is designed to be the most parsimonious byte-squeezing garbage collector ever made, because the heap is tiny. The heap is like 50K or something that you run on an original message pad, maybe less. So it doesn't care how slow it is. It just wants to make sure that you don't run out of memory if you don't absolutely have to. Whereas if you have a little more room, you can use a garbage collection algorithm that is just much faster. It doesn't take as much overhead away from the program. And things like JIT compiling the program, if you have enough memory to do that and enough speed, that makes everything faster too. So I think there are just a lot of low-level compromises that could have just gone away if you had 8 megabyte, 300 megahertz Newtons. It just never got that far. I think there could have been a whole 3.0 revision that would have been as much of a leap over the 2000 as that was over the, the 130. Just doing obvious stuff. So then who knows what might have happened.
Oh, and the latest devices really went above and beyond what we had already seen in the original message pad and the 110 and 120s and stuff like that. So it was just amazing. It was just amazing. And the handwriting recognition was perfection. I mean, 99% in my case. I might have good calligraphy, but regardless, it was fantastic. Fantastic.
Yeah, and I'm sure Larry had some compromises in that code because he didn't have any space or CPU either. So it would have been even better if you had more room and more time and a faster processor.